so I'm just going to highlight some important events in the history of the hydrogen fuel cell. So in 1802, Humphrey Davy became the first person to really discover the modern day fuel cell technology, and he did this by complete accident. Almost 148 years later, in 1950, GE became the first company to really utilize successfully the hydrogen fuel cell. In the 90s, stationary large hydrogen fuel cells were created, and these new stationary large hydrogen fuel cells could power buildings, and they actually still do today with quite a bit of success. And nowadays, Honda and other companies have pledged to create hydrogen fuel cell cars, which have actually driven over 10 million miles and are very successful. Also, new developments with Virginia Tech have also led to large amounts of hydrogen being extracted, which have allowed hydrogen fuel cells to become much cheaper. So a question you may be asking yourself right now is, what is a hydrogen fuel cell? Simply put, a hydrogen fuel cell is a device that uses oxygen and hydrogen to create electricity. In addition, hydrogen fuel cells can replace a lot of things in your everyday life. These include batteries, the engine in your car, and even the electrical lines that flow to your house. So what are some important terms to know? So the first important term is obviously hydrogen, one of the gases that powers the fuel cell, oxygen, the other main gas that powers the fuel cell, and lastly, electrolysis. Electrolysis is the main process that powers the fuel cell. And how has all of this been discovered? Most of this has been discovered by complete accident and just accidental discoveries. And how can we measure hydrogen fuel cell success in the real world? It's pretty simple. All you gotta do is really just see how successful it is can be implemented. Okay, so the dependent variable in this experiment would be force of current in volts, the independent variable would be different type of power source used, and the control variables would be keeping the same materials, using relatively new materials including batteries, and keeping the general atmosphere the same. Okay, so you're going to need a few things for this experiment. First, you're going to need the Solar Hydrogen Education Kit that's made by Horizon. It can be found on Amazon. You're going to need some distilled water. You're going to need a variety of batteries, for example a 9-volt, a AA, a D, a sort of smaller electronic battery, and a C battery. And lastly, you're going to need a voltmeter or a multimeter. Okay, so the first step you want to take in this process is actually building the hydrogen fuel cell. It's really simple, really easy, just follow the instructions and you should be fine. Okay, so once you see bubbles in the hydrogen tank, you are done with this part of the experiment. Okay, so you just saw the bubbles in the hydrogen tank. Now what we're going to do is plug in your two included leads with the red to the red side and the black to the black side. You're going to take your multimeter, turn it on, and you're going to go with the red lead to this red lead, and the black lead to this black lead. And you can actually see that we get about 1.4 volts from the hydrogen fuel cell. Okay, so to measure a regular voltage from a battery, you're just going to take one of your leads and put it on the crest of the D battery right here. And you're going to put the other lead on the smooth part. And you can see we get about 1.5-ish for this battery. Now, for example, for a battery like this, it's just a little differently, but you take both leads, and you see we get about 9 volts. And lastly, for a battery like this, just put the battery on and sandwich it between the two leads, and yeah, we get about 1.5 volts. So for your experiment, you're basically going to do your procedure 4 times. And you're also going to note down some important things, such as volts per trial per power source. Okay, so here's the raw data collected from trials 1, 2, 3, and 4. So right here we have a bar graph reversing power source against a force of current. And we can see that for the most part the hydrogen fuel cell was able to keep up with most of the batteries, except for the 9-volt, which averaged, of course, much higher than everything else. Okay, so this is a line graph for saying force of current in volts versus time in minutes. So the blue line represents the hydrogen fuel cell, and the green line represents all of the other batteries except for the 9 volt, just to keep things fair. So going by intervals of minutes, we can see at 2 minutes, the hydrogen fuel cell is pretty close to the batteries. Keep in mind that this y-axis scale is pretty small, it's only about half a volt. If we move to the 4-minute interval, we can see that the hydrogen fuel cell has lost its some voltage because the electrolysis process is slowing down. And lastly, if we look at the 6-minute interval, we can see the hydrogen fuel cell is still getting incrementally smaller in its voltage because of the aforementioned electrolysis slowing down. However, the battery remains pretty consistent throughout. Okay, so my hypothesis was somewhat correct. Well, the hydrogen fuel cell did emit 1.4 volts, which is comparable to most small batteries. It did not sustain this, as seen by the line graph earlier in the presentation, which obviously showed that the hydrogen fuel cell over time lost its power, while the battery maintained it. In this experiment, there's only really one real surprise. The hydrogen fuel cell actually emitted 1.4 volts, which is actually pretty surprising to me. Lastly, some questions for future use. My main question would be, how effectively, in the real world, can hydrogen fuel cells replace things? I.e., like your engine in your car. How effectively would a hydrogen fuel cell replace this?